In data representation, not all loss is accidental. Some loss is deliberate. This is where truncation comes in. Truncation is the process of shortening data by removing part of its representation. The removed portion is not rounded, approximated, or compressed. It is simply discarded. Once truncated, the lost information cannot be recovered. At a high level, truncation defines a hard boundary. Anything beyond that boundary is ignored. A useful metaphor is cropping a photograph. When you crop an image, you are not blurring the edges or resizing the scene. You are cutting off part of the picture entirely. What remains may still be clear and useful, but the missing portion is gone forever. Truncation works the same way with data. So, what exactly gets truncated? Truncation can apply to numeric values, text, time series, logs, identifiers, or even entire records. It occurs whenever a representation is forced to fit within a fixed size, length, or precision. In numeric data, truncation often happens when decimals are removed. For example, truncating a value of 3.9 to 3 does not approximate the value. It removes the fractional component entirely. The result is systematically biased downward. In text data, truncation occurs when strings exceed a maximum length. Characters beyond that limit are dropped. Names are cut off. Messages lose endings. Identifiers become ambiguous. In time-based data, truncation may remove sub-second precision. Events that occurred at different moments collapse into the same timestamp. In logs and telemetry, truncation often limits record size. Large payloads are cut. Context disappears. Debugging becomes harder. How does truncation happen? Sometimes it is explicit and intentional. A system may define a fixed width field, a maximum string length, or a bounded numeric type. Values that exceed those limits are truncated by design. Other times, truncation is implicit. It occurs during type conversion, serialization, database insertion, export, or integration between systems with incompatible constraints. The truncation happens quietly, without error. This makes truncation especially dangerous. Why do systems truncate data at all? The primary reasons are performance, storage, and simplicity. Fixed-size representations are faster to process. They reduce memory usage. They simplify indexing and transmission. In high-throughput systems, truncation can be a practical necessity. Truncation is also used to enforce limits. It can prevent unbounded growth, protect systems from malformed inputs, and ensure predictable behavior under load. But truncation always involves trade-offs. Its defining feature is irreversibility. Unlike rounding, which preserves approximate magnitude, truncation introduces systematic distortion. It always removes information in the same direction. Over time, this bias accumulates. Another feature of truncation is invisibility. Truncated data often looks valid. Values fall within expected ranges. Records load successfully. Systems continue operating normally. But meaning has been reduced. A truncated value is not just smaller, it is less informative. The implications of truncation are far-reaching. In analytics, truncation can distort distributions and bias aggregates. In finance, it can systematically understate values. In identifiers, it can cause collisions. In logs, it can hide critical context. In machine learning, truncation can erase weak signals that matter at scale. Features lose nuance. Models lose sensitivity. Perhaps most importantly, truncation limits future questions. Once data is truncated, you cannot later decide that you needed the discarded detail. The representation has already enforced that decision. Professional data systems treat truncation as a design decision, not a side effect. They document where truncation occurs. They justify why it is acceptable. They preserve raw data when possible. And they avoid truncation in irreversible pipelines unless absolutely necessary. Because truncation is not just about making data smaller. It is about deciding permanently what no longer matters. And that decision should never be accidental.